Hello, it's great to be here today. So thanks for the invitation, and let's start. Automated tests as quality pipeline data fit. So basically, how to reuse the current existing automated tests for different purposes, for different elements of quality pipelines. Just a few words about me. I'm Tomasz Konieczny. I currently work for RAW as senior QA engineer, and I'm mainly responsible for test architecture and infrastructure. And as I mentioned, this is completely personal project, so it's not related to the company I work for. And just to clarify, by automated tests, I mean this high-level end-to-end tests that are mainly used for regression purposes. So I would say typical functional tests, because that's their main goal, to check the most important functionalities to verify if they are still working correctly, and if we can, for example, release the application. So these tests are like designed to check functional things. But let's say the example application, I installed PrestaShop locally, and that's the test store that's available. Let's see how these functional tests may look like. I implemented the example scenario. So for example, if we'll be testing the user flow, one of the most important things will be definitely the cart functionality. So if the user is able to add specific products to the cart. And let's see this test. We have a really simple scenario here: add product to cart. And basically the user is on the main page. The user opens some interesting product. Then the user adds this product to the cart, proceeds to cart, and the product should be visible there. So really simple scenario. I used Gherkin here to visualize the specific case, but it's not only about Gherkin, it's how these tests are designed. I mean, these end-to-end automated tests are like function-driven. So that's their main goal, and these tests are designed in this way. So how to reuse them for completely different purposes, like for example, non-functional tests? Well, that's what I will show during today's presentation. But let's think about things that we already have if we execute these automated tests. Let's think about test artifacts. Well, in most cases, we will have some execution logs, for example, logs from test runner, or some additional custom messages that may be useful for us, or for example, screenshots. So in case of any failure, we will get screenshot, and we'll be able to visualize what exactly happened. It's really useful for debugging purposes. And also maybe some application logs, so logs from front-end application, from back-end application, maybe some infrastructure logs. And if we correlate it with test execution, then we'll get tons of useful data that we may use for different purposes or for debugging. But there's also one more thing I usually add for this, I would say, standard set of test artifacts. That's HIR file or HTTP archive. It's basically the huge JSON containing a history of every single request and corresponding responses. And what can we do if we have this file? Well, we can just drag and drop it to the, for example, Chrome browser's DevTools network tab, and we'll get the exactly same output we would have normally there. So basically, every single request we can check, and it's really useful for debugging purposes. We can even extend this concept. I mean, we can use one of the HIR viewing libraries. We can display this logs directly inside the build pipelines. So again, we can even simplify this here. But how to get these files in the easiest way? Probably the easiest option is to use proxy. And in the past, I used browser mob proxy. Currently, I use browser app, so that's basically the actively maintained fork. And this proxy is designed specifically for testing purposes, for integration with test frameworks. So let's set up this tool. Let's start the browser app proxy server. I usually avoid running any dependencies or binaries locally on the host side, so I used Docker-based setup. I use Docker Compose, and basically I created the complete setup for every single thing I will show during today's presentation. So it's not only some text on the slides; it's something I implemented. So I had some Selenium-related containers, so Selenium Hub, browser, Python container for running tests, and I just extended it with one more, so proxy, container name browser app. And there aren't any ready images, so I had to build a custom one. So there's only one argument, download URL. So which here I just pass the binary location. I got it from the GitHub page from this project, and that Docker file is really simple. It's based on the manual from browser app proxy. So I used OpenJDK image, then I read this download URL parameter, wget to download this binary, tar to extract it, and a very simple entry point, browse out proxy, so it will just start when we will start this container. And the server part is ready. I mean, if you don't want to use Docker, you can just run this binary locally. If you have Java installed on your operating system, you can just start it locally. The second thing we'll need to do here is to integrate it with test framework or test runner to be more specific. And there are two different options here. One of them is to use dedicated libraries, if there is some library dedicated for specific programming language. The second option is to use REST API, because browser app proxy can be controlled with REST API. It's really simple to use. I used this option in the past, so it's all about doing 3 requests. So opening the port, starting logging, and getting the HRR file in the end. But today I used the second option, so libraries. I implemented this example test in Python. So there's a library named browser proxy py that can be used to control this proxy in the even easier way. So there are 2 things we will need to do. We will need to start logging before the execution of actual tests, and we will need to stop the logging after the execution. So we can use, for example, before and after scenarios or anything, any other actions we'll have in the test framework we use. So we just need to start initialize proxy before the test execution, start logging, and also configure the test framework. So, for example, Selenium in this case. But let's start with the proxy part. I use this browser proxy py library and a remote server to be more specific. I will be connecting to the remote server because this proxy will be running inside the Docker container, but it's also possible to use it locally. So if you will have this binary locally, you can use this library to control it, and this library will even start this binary, this proxy server. Then we need to configure it. As I mentioned, I use remote server, so there are 2 parameters here, so URL and port. And that's all we need to connect to this proxy instance. Then we need to initialize it to create proxy instance. It will open port here, and then we have some configuration. So proxy options, if we want to capture headers or capture content or capture binary content. In most cases, I used only the first 2 of them. So I captured headers and content because these are the most useful. But sometimes you might probably also need the binary content. So it's good to know that it's also possible to do it. And then we can start logging. So proxy new iter. We can pass some custom metadata here. So in this case, feature name and scenario name. And we can pass these proxy options here. So what exactly should be logged. That's all we need to do related to proxy server. We also have to configure the test framework now, or the browser to be more specific. So I used Selenium as mentioned. We will need to set browser options or Chrome options in this case, because I used Chrome browser. And it's all about adding 1 additional argument, so proxy server, and we will pass the URL and port again here. And then we just have to assign it to the specific browser capabilities. So again, I used remote driver here because Selenium Hub will be running inside the Docker container. So I connected to the remote driver. So that's this config hub URL. And there's also 1 more thing, desired capabilities. So that's where I translated these browser settings to capabilities. And the browser will now connect with this proxy instead of connecting with application directly. And the last thing we will need to do to get these HRR files is to save them to some file. So I opened the file named feature name, scenario name, so the same naming conventions in write mode, and I just JSON dumped the content of this JSON to this specific file. And we will now have this HRR file as additional execution logs or additional build artifacts. But what about these non-functional tests? Well, I will show you today 2 different examples. So one of them will be related to performance tests. The second one will be related to security tests, but it's probably possible to find some other cases that may be also useful. You'll probably be able to reuse this concept for different purposes, but just let's start with these 2 examples. So the first one, performance tests or API performance tests to be more specific. What's definitely useless here is the overall execution time. I mean, comparing overall execution times of end-to-end tests will be completely useless because the browser will spend most of the time on the rendering of the front-end part. So if you want to compare the specific requests, well, we can't use it in this way. But we have these HIR files. These files contain the complete history of requests, and we can use it for different purposes. We can use it as data source for performance tests. So let's see what's inside these HIR files. Let's see this internal structure. So at the beginning, we have metadata. So for example, which software was used to create this file. So in this case, browser proxy. We'll have start date time, so when this file was created. And we'll have ID, so that's this custom name we passed here. So cart at product to cart, because that's the test name that was executed. And then we'll have just one more thing, entries, and that's basically the huge array of requests and corresponding responses. Let's see the example request. In this case, get on the cart action show endpoint. And we will have the specific request, start date time, so when it was executed, time, so how long it took to finalize it. It will be really useful for performance purposes to measure execution times. And then we have the complete request related data, so method, get, URL, so cart action show. We'll be using this request URL to filter to find specific requests, and then we'll be connecting them with different execution times, and we'll be extracting some data from it. Then we have things like cookies, headers, query string, post data, etc. These aren't that useful for the specific purpose, but it's good to know that they are also available. So we have just every data that we may need for analyzing requests here. Then we have the corresponding response, so status 200, everything is okay. Cookies, headers, content, etc. again. And then we have more detailed timings. So instead of just one more time, we also have more detailed ones. So for example, how long it took to send the request, how long it took to get the response. And that was just very simple GET request. So these timings may be very simplified. But in case of more complex one, for example, in case of post requests, other ones will be also visible here. So we can also use them for performance profiling. And it's all about filtering and aggregation. So we can create the list of endpoints that we want to profile, and we can extract this data from specific files. So for example, this get request on cart action show, how long it took to get the response. And it's all about getting this data, aggregating them, and calculating some metrics. But which metrics? I would say almost the same that in case of standard or classic performance tests. So for example, response times, minimum, maximum, average. Well, if anyone needs average, or percentiles, or information about failures, because if we got 500 error, then we don't care how fast it was. So it's also very important to think about failures to also handle them properly. And we can also correlate it with resources usage, with infrastructure data, infrastructure logs, and we will have more data that may be analyzed. But what about load generation? Because if we'll be executing just one test at the same time, it won't provide us any useful data related to performance. Well, it's one of our main goals in case of running end-to-end tests or functional tests should be to make them as fast as possible, to reduce execution times as much as possible. So probably the easiest way to achieve this is to execute them in parallel. So basically, the highly concurrent executions should be our main goal, because if these tests aren't fast, they are just useless in most cases. If we would need to wait like hours to get the results of functional tests, we won't be able to integrate them in the development process properly. So this should be our goal in case of performance tests. And I also showed it in the one of the previous talks when I showed how to speed up end-to-end test execution hundreds or even thousands of times using AWS Lambda. And the side effect was that these tests were able to kill application environments. I mean, the slowest ones, at least. So one of the additional features I implemented in Test Runner, or Test Scheduler to be more specific, was concurrency limit. So ability to limit the target concurrency. So instead of running like hundreds of tests at the same time at slow development environments, I was able to limit it to, for example, 50 or 100 tests running at the same time. The second thing I implemented is ramp up. So ability to start it with lower concurrency and then increasing it up to the target one. And it may be funny, but these two functionalities are known in most cases from performance tests. These are two parameters we configure in most of the performance tests. So what should be the concurrency and what should be the ramp up if we want to give the application time to scale up. And I implemented these things in case of end-to-end functional tests. So I was really able to generate really significant load and even kill the application environments if I set too high concurrency. So it's all about reusing things that we already have for different purposes. But what about consistency of results? There are two things that we'll need to think about. So one of them is the stable performance test set, because we'll probably add some additional tests like every day. And if we will be running completely different test set every day, we won't be able to really compare the results, compare these metrics that we'll get from these HRR files. So it's all about keeping some dedicated performance test set that will be more stable. So we'll add additional tests to this test set maybe instead of every day, maybe once a week. So we'll be able to compare the results from whole week. And they don't even need to be the completely separate test set, and maybe just the part of the existing test set that will be executed at the beginning. And that's the second thing. So deterministic execution. We want to execute these tests at the exactly same way, the same order, with the same concurrency, because otherwise we won't be able to compare these results that we'll get, and they will be completely unpredictable. And the question is, can this concept replace the standard or classic performance tests? Well, probably this question should be more about, is it the goal? Should these concepts replace them? I mean, this concept should be great first step before the introduction of proper or classic performance tests. It would be a great, very valuable feedback for the implementation of like classic performance tests, because it can provide us a lot of useful info. And one more thing is that it can also extend the classic performance tests, because we may design them to track specific things, but we can also get this additional feedback in a very easy way. So it's all about reusing things that we already have, because the feedback may be always really valuable. And the second thing is that this concept can give us something like end-to-end performance tests. Because in the case of classic ones, we would spend most of the time on designing them. I mean, trying to imitate the user flow. We'll be calculating the specific requests. We'll be calculating proportions of specific requests to simulate, to imitate this user flow. And here we already have this user flow. We don't need to imitate it, because this end-to-end functional test goes through user flow, and it's really similar to the one that target user will, how the target user will use this application. So we already have the proper test, proper request proportions, etc. It's all about getting data that we already have. So it's again all about reusability. And the second example I will show you today is reusing it for security purposes. So OWASP ZAP. If you don't know this tool, it's a really great open source automated security scanner that can scan the application in very different ways. It even contains the crawler that goes through the whole application and just guesses the different endpoints. But today I will show you one of the options that's based on OpenAPI or Swagger manual. So it's basically possible to use OpenAPI or Swagger-based documentation as input for OWASP ZAP, and it will scan the application based on this manual, based on these provided endpoints and settings, etc. But it's also possible to reuse again the HRR files that we already have. It's possible to use some HRR to OpenAPI converter. If you check the official OpenAPI website, there are a few example libraries there that you can use to just convert these HRR files that we have from the execution of functional tests, and we can use it as input for OWASP ZAP to get more detailed feedback. And we can even combine it with OpenAPI documentation if we also have it. So we will get more detailed feedback, and it's especially useful in case of multiple applications, because OpenAPI manuals will be mainly related to single applications, single microservice, and these functional tests go through the whole flow. So if we have a few applications, the user may go through this complete flow in a few applications. So we may get more detailed feedback. We will get more data for input for this OWASP ZAP. Will it result in automated security tests? Well, that's the question if these automated security scanners can be considered as automated tests, because these tools will definitely scan the application in the automated way, but we'll still have to analyze the results. We'll have to classify if some possible bug is the real security threat, or it's just a false positive. So we'll be creating the list of ignored false positives. We'll be maintaining it, and that's how we usually work with tools like this. So it's all about keeping up-to-date list of false positives. And well, it would require some work at the beginning if we'll be introducing this tool, but then it's all about updating the differences. So we'll have the list of false positives that should be ignored. But if we add some additional endpoint to the application, it will again return the list of possible security threats. And we will need to, again, classify if something is a real threat, a real security bug, or something is just a false positive. And we'll be updating this list of false positives maybe even once a few days. And at the end, I will say just two more things. It's all about thinking outside of the box. I mean, and sometimes we don't even need any additional, we don't even need to implement any additional things. We already have everything that we need. And it's all about reusing things that we already have. So that can save a lot of time during the development process. I mean, for example, performance tests, we sometimes don't even need to execute them because we have everything. We have infrastructure logs. We can extract the data from these functional tests, and we can calculate metrics based on that. We don't need to even use some tools like JMeter or Gatling or anything like that. And this will allow us to speed up the delivery of software. And that should be our main goal, to deliver something that's actually working correctly. And we can't only think about functional part, we also have to think about these non-functional things like performance or security and usability, because these things are also very important. And that would be all. Thanks. I hope you enjoyed the presentation. And if you have any questions, I'll answer them now.